Hey there, fourth graders, Mrs. Smith here. Today we are doing Unit 2, Lesson 11, which begins on page 69 of your math book. So let's get to it. Today we're talking about problems that are a little bit messy. Problems that have maybe too much information, problems that have secret hidden questions or too little information. And then we'll have a little puzzle penguin at the end to figure out a common mistake that people make. So it's important that we're practicing these kinds of problems because in life, whenever you're standing in front of, your new living room and your new apartment and you're thinking, I want to get a rug in here, or I want to have a table that fits through my door or whatever. There's a lot of information to consider, and you have to know which information is important, which information is not, and neaten it up so you can figure out what's going on and, not waste a ton of time calculating the window size when you need to just know the area of the door, Okay, so it says discuss problems with too much information. A word problem may sometimes include more information than you need. Read the following problem and then answer each question. Mrs. Sanchez is putting a border around her garden. Her garden is a rectangle, like this, with dimensions 12 feet by 18 feet. So I'll assume this is the 12 and this is the 18, and so this is also 12 and this is also 18. The border material costs $3 per foot. How many feet of border material is needed? Identify the extra numerical information. Why isn't this needed? Think about it. Hit pause, think about it, and when you think you have an idea, hit play. So we need to know how many feet she needs, right, of the border, which goes all the way around. So we're basically going to find the perimeter. And we're going to use all these 12s and 18s and get that distance around. That'll be the number of feet. The question is only asking how many feet. The question is not asking how much money she needs to have or like how much it will cost, which means we need the 12 and we need the 18. We need to know it's a rectangle. Do we need to know the cost per foot for this? No, we don't. Absolutely not. So we're going to just give it a gentle cross out. I would highly recommend not fully scribbling something out like that because every once in a while you might accidentally cross out the wrong thing and you want to still be able to see what it was, right? So you can change it. Identify the extra numerical information. We don't need to know the cost per foot to solve for how many feet? Because the question was how many feet. So now, even though we've been doing a bunch of multiplication, we're actually not going to be multiplying this because we're not finding the area of inside the shape. We're finding the perimeter, the border material, the distance around the whole thing. So what we're going to do is we're going to have a 2 times 12 and then a 2 times 18 and then add those up, or just add up 12 and 18. Let's do that because I know 8 and 2 make it 10, and then we'll do that times 2. So 8 plus 2 is 10, 30. 30 times 2 equals 60. So she just needs 60 feet. Who cares how much it costs? Maybe she's got a friend who's going to give it to her or something like that. So we did 12 plus 12 plus 18 plus 18, and it equals 60 feet. Okay, solve each problem. Cross out information that is not needed. Judy bought a CD for $10. It has 13 songs. Each song is 3 minutes long. How long will it take to listen to the whole CD? Think about what we don't need to know. We need to know how long it will take to listen. What do you think? Yeah, we don't need to know how much it costs. I'm going to just cross that out lightly so I can still see what it says. So we have 13 songs, 3 minutes long. Make a quick little area model. Break that 13 up into 10 plus 3. 3 minutes long, so 39. It'll be 39 minutes. So 13 times 3 equals 39 minutes. All right, Jerry has 64 coins in his coin collection and 22 stamps in his stamp collection. His sister has 59 stamps in her collection. How many stamps do they have altogether? What are we looking for? What do we care about? We just care about the stamps, which means we don't, in this case, care about what? The coins. Coins, get out of here. Who cares? So all together, so we're going to add those up. 22 plus 59. 2 plus 9 is 11. 2 plus 5 is 7. Plus 1 more is 8. So 81 stamps. Coins, schmoins, right? We don't need them. All right. Number 5. Adrian has been playing piano for 3 years. He practices 20 minutes a day. He is preparing for a recital that is 9 days away. How many minutes of practice will he complete before the recital? I'll give you a moment to think. We want to know how many minutes he will do. Not has he done so far in his life, but will he do? So that means if we know he has 9 days and he does 20 minutes a day, we're not concerned with his previous piano experience. So we're going to do 20 times 9. We'll break this, factor that 20 into a 2 times 10, and then bring down this times 9. So then we have, I'll do the 2 and the 9, so 18 times 10, which is 180 minutes. All right, turn that page. Let's take a look at the back. So this is some missing information, okay? When solving problems in real life, you need to determine what information is needed to solve the problem. Read the following problem and answer each question. The campers and staff of a day camp are going to an amusement park on a bus. Each bus holds 26 people. How many buses will be needed? Do you have enough information to solve the problem? Well, we know each bus holds 26 people. But what else do we need to know? We need to know how many people, right? We know that there are campers and staff. We know that they're going on the bus, but we don't know if there's 13 campers. We don't know if there's 130 campers. We just know that the bus holds 26. So we need to know how many people are going. So no, we don't have enough information. We need to know how many people are going. And that could be like, you know, the number of campers plus the number of staff, but we need some numbers to solve that, right? Determine if the problem can be solved. If it cannot be solved, tell what information is missing. If it can be solved, solve it. Richard is saving $5 a week to buy a bike. When will he have enough money? Can it be solved? Okay, you ready? No. So it can't be solved because we need to know how much money the bike will cost, right? No, we don't know the price or the cost of the bike. Is it $100? Is it like a fancy racing bike that's like $1,000? Is it from a garage sale? It's $10. We have no idea, right? We can't solve that. Natalie wants to find out how much her cat weighs. She picks him up and steps on the scale. Together, they weigh 94 pounds. How much does the cat weigh? Well, we know the weight of her and the cat, which is 94. We want to identify, there's a little math mountain, so there's Natalie and there's Cat. Together it's 94. What would we need to find that cat? we would need to know how much Natalie weighs. So no, we don't know Natalie's weight. If we did know Natalie's weight, then we could subtract that and find the weight of the cat. But without it, we're out of luck. Okay, 9 and 10. Phyllis wants to make 8 pot holders. She needs 36 loops for each pot holder. How many loops does she need? We know the number of pot holders. We know the number of loops. So we just are finding out the product, right? So we can go ahead and multiply that. 36 times 8. So 8 times 3 is 24. So 24 tens, 240. 8 times 6 is 48. So 8 times 36 equals 288 loops. So that was fine, right? For one of the problems that could not be solved, rewrite it so it can be solved and then solve it. So I'm going to choose one. You could choose the same one or a different one. I'm going to do Natalie weighs, so for number 8, if Natalie weighs 84 pounds, then the cat would be Natalie weighs 84 lbs. That's how you abbreviate pounds for some reason. So then it'd be 94 minus 84 equals 10 lbs for the cat's weight. Okay, let's go ahead and turn that page. Now, sometimes you have problems that have a secret half-step question, which you have to solve, even though nobody asks it, in order to solve what the real question is. So let's take a look at this one. Miss Norton bought 2 packages of white cheese with 8 slices in each pack. She bought 3 packages of yellow cheese with 16 slices in each pack. How many more slices of yellow cheese than white cheese did she buy? So what do you need to find? What do you think? You need to find how many total slices she has of each kind. So rather than 2 packages of 8, we need to like figure out what that number is. So white equals 2 times 8, which I've memorized, is 16 slices. And then yellow equals 3 packages each with 16. Oh, so yeah, way more yellow. So then if we do 10, 6, 3, 3 times 10 is 30, 3 times 6 is 18. So she had 48. And then we can set up comparison bars. Before I do that, what do we need to find? The total number of slices per type of cheese. So yellow is more, it gets the big bar. White is small, it gets the little bar. White has 16. Yellow has 48. 48 minus 16. 32 is the difference. So the hidden questions were how many of white? How many slices of yellow? So then we'll answer those. We already did that already. So 2 times 8 is 16. 3 times 16 is 48. And 48 minus 16 is 32. All right, now we're gonna do the same kind of process down with these ones. So I want you to think about what we just did. If you're feeling up for it, you can go ahead and try it without me. Maurice had 6 boxes of markers. June has 5 boxes of markers. Each box contains 8 markers. How many markers do Maurice and June have all together? Okay. So I would say the hidden question is, how many markers does Maurice have? How many markers does June have? So for Maurice, we'll do 6 times 8. And 6 times 8 is 48. And June has 5 times 8, which is 40. So that's a total of 88 markers. Okay. Now let's flip over and take a look at this variety pack we have here. Solve each problem and show your work. Mr. Collins counts 54 cartons and 5 boxes of paper clips. Each carton contains 8 boxes. A box of paper clips costs $2. How many boxes of paper clips does he have? So we're asking how many boxes. So he's got the 5 boxes and the 54 cartons. Each carton has 8 boxes and a box costs $2. How many boxes of paper clips does he have? It is not asking what? Like how much money he spent, right? So do we need to know the cost? No, we don't. That's just superfluous or extra information. What we do need to know is how many boxes he has inside the carton section. So we'll do 54, 50 plus 4 is 54. 8 over there, 5 times 8 is 40, so 5 tens times 8 is 40 tens, or 400. 8 times 4 is 32, so 432 plus those 5 from earlier, 437 boxes. And we don't care how much they cost because he has a lot, so maybe he doesn't need to buy anymore. He's like, I'm good on paper clips, thank you very much. Ms. Washington has 5 cartons of black printer ink. She has 4 cartons of color printer ink. Each carton contains 48 cartridges of ink. How many ink cartridges are there in all? So we want to know how many cartridges there are in all. It isn't saying specifically black ink or color ink, so we're assuming all of it, so we do need to figure out all of that. I think this one has a secret half-step question. We know the cartons for both colors, but we don't know how many cartridges for both colors, right? So what we can do here is we can multiply both of those by 48, the 5 and the 4. So let's do that. 48, 5. 5 times 4 is 20, so 5 times 40, 200. 5 times 8 is 40. That's 240 for the black. Plus, I'll do the color. Four times 40, 160. 4 times 8, 32. So 192. Add that up. 92 to 13. So 432. Cartridges. Okay. Number 18 is a puzzle penguin. So let's figure out what he did wrong. My school, dear math students, my school is collecting cans for the animal food, or the annual food drive. There are 608 students in the entire school. A can of soup costs about $1. Each student will bring in 3 cans for the food drive. I wrote this multiplication to find the number of cans the school will collect in all. Okay. Let's see. So, I'm glad to see that they didn't try to, find the dollar amount. That would be silly. I'm going to set up the same multiplication, and I'm going to try to go step by step and see what they did. So 3 times 8 is 24. I am seeing what they did. 3 times 0 tens is what? 0, right? But he did 3 times this 2. And really, you're just supposed to add in that 2. So 3 times 0 is 0 plus 2 more is that 2. And then 3 times 600 is your 1800. So rather than multiplying 3 times 2, they should have just added the 2. You were only supposed to add those 2 tens to the 3 times 0 equals 0. All right, my friends, check and see if you have an assignment, and I'll catch you next time. Thanks for joining me. See you later. Bye-bye.